some of them will already be factored for you. I made the assignment about half and half. Then you're going to sketch a graph of the polynomial. We've done these two things before. This might look a little different for you. I think Mr. Bernard does some sketching a little bit different than I do, but I'll kind of explain it to you as we go. And then you're going to select the correct intervals based on whether you want it to be above or below the x-axis. Above means that it's going to be a greater symbol. They both say below, because the one on the bottom is supposed to be above. This one. So if you have a greater than, that means above. A less than means below. It is much easier if you understand what those two symbols mean. The ones that are pointing to the left are less than, which is easy to remember because less and left both start with L's. Yeah, they actually both start with LE. Then you're going to write your answer in interval notation. Keep in mind that we are using parentheses around symbols that don't have the little bar underneath and brackets around symbols that do. Okay? The brackets mean or equals to. And you can never equal infinity, so they always have parentheses. This one shouldn't be too difficult on the solving side unless you're still figuring out factoring. And if you're still figuring out factoring, keep going. I promise it'll get there eventually. That is probably one of the hardest but most important topics we talk about. So as I go down to this first one, remember that as you are looking at a problem, and writing this down may be a good idea if you don't have your notes with you. Look for a greatest common factor first. So there's an x on all three of these, meaning we're going to take an x out. And when I say out, that means in front of the parentheses. And then you're essentially dividing everything that's left over by x, or taking everything down by a power. So this one's going to be x squared, negative 2x, and negative 3. And we've actually seen this one quite a bit, but it is kind of tricky. A lot of people asked me about this one when we saw it on the assignment. Once you've done that, you're factoring what's left in the middle. And if there's three things, 1, 2, 3, you want to find the two numbers that multiply to negative 3 and add to negative 2. If you need to come over to the side and make yourself a list, sometimes having that visual helps. Especially because there's only two options, and sometimes our brain can just get really tricked into between what the sign is supposed to be. We want negative 2 to be what they add to, so I want the 3 to be the one that's negative. So I want a positive 1 and a negative 3.
Then not be the opposite
in the parentheses. It's the same when we got to switch it though. So yes, you're right that it needs to switch. And then at the end, like Jared said, you want to switch them because you want to know what makes these 0. So if you want to make this 0 out front, it's just 0. If you want to make this 0, you're asking yourself what number plus 1 equals 0. And that's always going to be negative 1. In general, if you're taking something out of parentheses, a lot of times it ends up becoming the opposite. So we have 1, 2, 3 zeros. Always make sure that that adds up to your degree, which was x cubed, so you're good to go. This is the part that looks a little different for you, Ellie. You're going to draw yourself a number line, basically. In the middle, just so you know where 0 is going to be, draw yourself a little y-axis. If you're doing this on notebook paper, use one of the lines for the horizontal one. And then I need to put points at 0, negative 1, and 3. And then this is the part where we're going to be a little loose with the rules. Look in front. There was no negative in front of the x cubed. So that means that the right side of our graph is going to go up. If there is a negative, that side would go down. And I'm not talking about the zeros, I'm talking about right here in front of the polynomial. We don't have any double roots on this one, so it's going to go all the way through them like this. And then we had a less than symbol. Less than means I care about the parts that go underneath. So I care about this part, and I care about this part. Always sketch the polynomial first, otherwise it's going to be really hard to tell. Okay, and this did not have the little line underneath, so we're kind of considering both of these as open circles, or all three of these. If you want to make them open, it doesn't really matter right there. So this interval right here is going to go from negative infinity to -1. And they both get parentheses because there's no closed circle. This isn't a less than or equals to. And then I want this one right here as well, which goes between 0 and 3. And whenever we write two intervals, we put that big U in between them. And that's pretty much it. The part that's going to be a little different is when you write your intervals. Sometimes it might be only 1. Sometimes it might be 2. Usually it's not going to be 3, but it's possible. That's the part you can't say is the same each time. You just kind of have to do a little bit extra thinking here at the end. Okay. Let's do another one. Scroll over here to the right a little bit. Give you a second to write it down if you were working on it on notebook paper. The first factor is x squared minus 1. And then you have x minus 4 in parentheses with a squared on the outside. And this time we're going to go greater than 0. So instead of wanting the parts below, we're going to want the parts above. That's really the only difference between these two problems. That, and if you want this to equal 0, that means x squared has to equal 1. Not just x, but x squared because there's an x squared on the inside. What are my zeros going to be coming out of that? Or what do I have to do to find my zeros now? Yeah, square root. And when I square root, that means I have two answers, positive and negative. Okay, square root of 1 throws some people off sometimes because it's 1. The square root of 1 is still 1. So we have 1 and -1. Because whenever we do that square root, we need both. And then our 0 from over here is just going to be 4. But since it's got the squared on the outside, it is a double. If it is a double, what does that change about the graph? Yeah, it bounces. So when I get to that 0, I'm not going to go all the way through. Okay, move this over a little bit. Go ahead and draw it over here. I need 4, 1, and -1. I'll go ahead and draw those as open circles. I kind of messed up the one on the right, though. And there's no negative in front of the parentheses. So we're looking kind of like right here is where we'll be if there is one, and there's not. So this one is going to start by going up as well. But this one at 4 isn't going to go all the way through down here. Since it's a double, it goes straight back up like this. But all of the others, it will go straight through like normal. Hopefully that's kind of coming back a little bit. Then we wanted the parts that were above. So that's going to be this part, and this part, and this part. So there are 3 intervals. One of the kind of tricky parts is that this is an open circle. So it doesn't just go from here all the way over to the right. It actually has to stop there. So we're going to go from negative infinity to negative 1, positive 1 to 4, and 4 to infinity. And since this isn't equals to, everything gets a parentheses. You could technically say this one's a little bit more complicated since it has 3 parts, but it doesn't really solve differently. You just have to write a little bit more as your answer. All right. I'm going to go ahead and skip the other one that's already factored for us. If you really want the answer, I'll show it to you at the very end, but that way we can kind of keep rolling with the factoring. So ones that are already factored, like this one, are a little bit easier because you don't have to do the factoring yourself to find the zeros. However, if it's already factored, that usually means it might have a few more zeros. So we're going to move down to the one that's x to the 4th. Minus 7x squared minus 18 is less than 0. If you want to jot that down, you have notebook paper. Okay, if there is an x to the 4th, and this one is an x squared, and there's nothing on the end, you are going to find the two numbers that multiply to negative 18 and add to negative 7. The only difference between one that was originally x squared instead of x to the 4th is when you go to put it in your parentheses, whatever was in the middle has to be what's out front. So those are always going to match the middle. And then multiplies to 18, I'm not even going to write down 1 to 18 because I know that's not it. 2 and 9, 3 and 6. That's it. And I want one of them to be negative. I always guess the number on the left just for right now. My top row adds to 7. My bottom row adds to 3. I want the one that's 7, except it says negative 7 over here. That just means I want the 9 to be negative instead of the 2. And then you do have to solve this. It's going to be x squared equals the opposite of what's in the parentheses. I am going to take a second to kind of review why. If you took this factor and set it equal to 0, the first thing you would do is subtract that 2 to both the other side. And then you need to take the square root. What happens when you take the square root of negative 2? Yeah, it's imaginary. So technically it's this. And remember that it always gives you a plus and minus. So if you have an imaginary root, there should always be 2 of them. The only real importance of writing that is to make sure that our roots add up to 4 in the end. And then on the other side, it would be x squared equals 9. Okay, because you would have x squared minus 9 equals 0. Add the 9 to the other side. And the square root of 9 is 3. When you go to graph this, all you need is the 3 and the negative 3. There is no way to graph an imaginary number. That is why it's imaginary. So you just sort of get to skip it when you come over here. There was no negative, so this side goes up, and it's just going to go straight through all of them. Like that. Technically, when it has imaginary roots like that, in the middle, the graph is going to do more of one of these, but I don't care if you draw that part or not. And then we want the parts that are below because it said less than. So that's just this part. From negative 3 to 3. That right there is most of it. We're going to talk about this last one, but if you are on Zoom and you would like to go work on the assignment, that is fine. Come tomorrow ready with your questions if you are on Zoom, because we'll get a little bit of work time here in just a second. All right, so another reason why I skipped the one in the middle left is because this one is very similar to it. It's got a lot of zeros coming out of the factors. A reminder that if there is a number in front of x like this, when you set that equal to 0, you're going to get the opposite of the last number, so I'm going to subtract 3, and then you're going to divide by 2. So you get x equals -3/2. We've talked about this a lot this year, and I've explained it a couple of different ways. Basically, it's always going to be the opposite of this number divided by this one. Okay, and then this one's going to be 6, but it's a double because it's got the squared on the outside. And -5. And I'm still going to draw mine over here because I want space down here to write the intervals, but it's going to get a little scrunched. 1, 2, 3, 4, 5, 6. As you're drawing your little tick marks, make sure you go out to the biggest one. So when you go out to 6 and -5, I'm just making sure I draw enough to get there. When I go to do -3/2, that's -1.5. So I'm going to put it right here in between -1 and 2. And I'm actually going to draw closed circles this time because of this. It's got the little line in it. -5 and 6. I've also seen some people when they draw theirs, they'll put a little star next to that one so that they remember when they're going to graph it in a second that that's the one that bounces. And that's fine. That's just like a trick or a tip that I've seen other people use that helps them. Okay, there's no negative out here, so this side goes up. Since that is the double, it doesn't go all the way down. It crosses or bounces back up like this, crosses through this one, and through the next one. And it's okay if your polynomials don't always look super pretty. It can be kind of awkward to draw, especially as you're getting used to it. This is a greater than symbol, so I want the parts that go above. So that's actually all 3 of those parts. And then I'm going to compare this one to the one above it. So, since it's too far, this one was an open circle, we had to separate it still. Since this one is a closed circle, we get to include everything from here going over to the right. It doesn't matter that it stops right here on the x-axis because you get to include that. So if this is included, you don't have to separate the intervals. If it's an open circle, you do. So this one's going to be from -infinity to -5. And I'm going to use a bracket because it's a closed circle. And this one's just going to be simply -3/2 to infinity. You don't have to stop at the 6 because it's closed. So it never crosses below, and it's okay for it to be equal to. I would also be okay with it. I'm going to box this as my preferred answer, but I would not count you wrong if you included this like this. If you kind of like separated them out. If you didn't see that it was closed and you could just keep going, if you wrote both, that would be okay with me. So it's really the same answer, you just wrote it in a little bit longer way. Okay, if it were to have said less than 0. That would be this part in between right here, and that's it. Just this one little loop that goes under from -5 to -3/2. And they would both, again, have brackets because they're closed circles. Either all of the circles are open or all of them are closed because they all come from the same original. And if it just said greater than and didn't include the little equals to underneath, you would have pretty much the same answers as here, except with parentheses, and you would have to choose this one. So if they're open, you have no choice but to list all 3 of them.